We'll be learning about charges when it is at rest and what happens when it starts to move. Semiconductor electronics, which essentially discusses the theory of semiconductors, transistors and diodes. So the first section will contain 15 questions, which is MCQs, where you'll have a set of 6 questions, out of which you'll have to answer 3 questions. Hey all, I am Hari Krishnan from the Department of Physics, Vidhyaashram PU College, Mysuru, the Temple of Excellence. And today in this class, we'll be discussing about what are the various topics and the areas we'll be covering in this year for PU second year under Physics. So these are the various chapters we'll be looking at in the PU second year Physics. So what is so special about them? Unlike the PU first year chapters, this year we are going to learn about what is electric charge and what is its specialities, how does it resonate a field around it, and the electrostatic potential, capacitance, current, electricity, moving charges and magnetism, magnetism and matter, electromagnetic induction, alternating current, electromagnetic waves, ray optics and optical instruments. The first chapter is electric charges and field. We'll be learning about charges when it is at rest and what happens when it starts to move. So the first 2 chapters is related to electric charges and its basic properties when it is at rest. So the field and its properties, quantization, everything will be studied under these 2 chapters, and we'll be discussing about the electrostatic potential, the potential energy, the capacitance and resistance of all these things. And then coming to current electricity, what happens when a charge moves? It creates electric currents. So we'll be learning about current electricity or electric currents in this chapter, and after that we'll be learning about magnetism. When a charged particle moves through a medium, it creates magnetic fields. Initially we will be learning about a charged particle which is in rest, and what happens when the charged particle moves. It creates current. So we'll be learning about current electricity, and after that, when a charged particle moves through a medium, it also creates a magnetic field. So we'll be learning about all the properties of magnetic field and its behaviors. So what happens when a moving charge creates a magnetic field? What is a magnetic field? What is magnetism? And all those basic properties will be discussed in these chapters, and how that magnetic field or magnetic particle behaves with its matter around it. Okay. And then we'll learn about electromagnetic induction, alternating current, and then we'll dive into electromagnetic waves, all the waves which has an electromagnetic properties such as energy waves, light waves, radio waves, thermal waves, everything will be studied under this. After electromagnetic waves, we'll be studying about ray optics and optical instruments, how we see the world, how the focal length of different objects are, how the lenses behave in various environments, everything will be studied in depth. So these are the first chapters we'll be discussing, and these are the marks allotted for each of the chapter. As you can see here, current, electricity, moving charges and ray optics bear a hefty ton of marks. If you look at this side of the board, you can see that this is the board allotted time for the completion of these chapters. But we'll be aiming to complete these chapters by this estimated time of completion. So we are hoping to complete each chapter before the board allotted time. After those chapters, these are the rest of the chapters. Wave optics, dual nature of radiation and matter, atoms, nuclei and semiconductor electronics. Wave optics. So we'll be discussing in depth about waves, how they behave and what are their properties and innate nature. Everything will be discussed in wave optics. And coming down, we can see that there is dual nature of radiation and matter. Don't get too afraid by these big words. These are actually simple concepts written down in scientific sense so that it sounds fancy. We have all heard about atoms and nuclei, but we'll be studying in depth and what essentially is these atoms, what are their properties, how they behave, how they become whole together and how they work in terms with each other. And in the last chapter, we'll be discussing about semiconductor electronics, which essentially discusses the theory of semiconductors, transistors, and diodes. And these are the mark distributions given to each chapter. You can see here the board estimated time and the estimated time of completion we will be doing. So we are going to finish each and every chapter before the board allotted time, and we are going to do it in a very efficient manner. So again, if you look here, we can see that the pattern is that we will start with a charge in rest and slowly make it move, creating current. After that charge moves through a medium, it creates a magnetic field, and that magnetic field and how it interacts with every matter around it will be discussed, and those properties will be scientifically analyzed and systematically assessed. And after that, we learn about alternating current and electromagnetic waves. After learning about charges which are in motion, we learn about waves and how it interacts with the matter around us, how waves are important for us, and how we are surrounded by waves. And after all that, we'll be discussing about ray optics and optical phenomena, how we see the colorful world around us, how we use lenses and different sorts of mirrors so that we can adjust and correct the world around us. And finally, we'll be dealing about wave optics, the dual nature of matter and radiation, which talks about the famous principle of photoelectric effect and other phenomena along the way. And we'll be learning about atoms, nuclei, and semiconductor electronics. So after this, we'll be discussing how the examination question paper pattern is going to be set and how you should attend each question. If you look here, you'll be having 4 parts: Part A, Part B, Part C, and Part D. So in that, Part A, 2 sections will be provided. So the first section will contain 15 questions, which is MCQs. So you will be given MCQ questions and you'll have to pick the correct choice for that question. And each question will be awarded 1 mark each. After the 15 questions of MCQ, 5 questions will be given in the format of fill in the blanks. The options will be given above and you'll have to choose the correct option and write the answer down. We'll be moving on to Part B, which will have 9 questions, out of which you'll have to answer 5 questions at least. And each question will carry 2 marks. And in Part C, which is section 4, you'll have 9 questions again and you'll have to answer 5 questions for that. And you will be given 3 marks for each question, which will add up to a total of 15 marks. So initially, the way the question paper goes is that you'll have an easy set of questions coming in, and then you'll have to start writing. You'll have to start explaining the question, and you'll have to go in depth answering each question. And finally, you will have a Part D, where you'll have a set of 6 questions, out of which you'll have to answer 3 questions, which will be given 5 marks each. So these are the questions where you'll have to answer with derivations, explanations, scientific phenomena, concepts. Everything will be discussed in depth in these questions. And finally, you have a section 6 under Part D. And finally, you'll have to answer any of 2 of the 4 given questions, which will normally be circuits, diagrams, or theories which need explanations. And for a visual comparison, this is how your question paper will look like. So first, you'll have a set of general instructions given to you so that you don't panic in the middle of your exams. So all parts are compulsory. You'll have Part A, B, C, and D, and you'll have to answer each and every one of those parts as per given instructions. And Part A questions, the first written answer will be considered for marking, which means that if you write 2 answers side by side, the first written answer will only be considered for your marks. And finally, you'll have to explain each answer with relevant diagrams, figures, equations, and formulas. So that is very important. And finally, if you have a numerical set of questions, you cannot answer directly the final result. You have to show each and every one of those steps in order to carry full marks. So these are the general instructions, and this is how the Part A question will look like. So you will be given a set of questions and there will be options. So you can pick any one of the appropriate options in the given list and you can write that down. And in Part B, you have a choice of writing 5 questions of your choice and you can write it in short words so that it is clean and precise. And finally, to introduce Part C, again, you'll have to write at least 5 questions out of the given questions. And for Part C, this is how your questions will be given. You'll have to define a law or a theorem or state a principle, and you have to do that with clean, precise actions. And finally, for part D, this will be the question paper pattern, which will ask you to derive, prove, or state some theorems with formulas, diagrams, and equations which you'll have to do promptly. To conclude, this will be the question paper pattern given to you. So your question paper will be out of 70 marks. Why 70? Why not 100 marks? Well, again, as you know from first year, 30 marks will be given to you for your practical examinations, and let us see what your practical examination has for you. So as I told you, your theory paper will be for 70 marks and the remaining 30 will be awarded for your practical experiments or your practical understanding of that theory implemented through experiments. So why do we need practical experiments? So that we know or you have understood the theory and you can apply that in real world application. These experiments are given to us so that we'll have an understanding that the knowledge you have gained through theory is applicable in the real world, or in simple terms, you know what you're doing. So these are a list of experiments we have to do in PUC second year. Out of these, we'll be doing select experiments. As you can see here, we have a list of 17 experiments, out of which we'll be doing a selected number of experiments. These experiments are directly connected to whatever theory you have been studying. You'll be dealing with electrical experiments, magnetic experiments, semiconductor electronics, and finally, you'll be dealing with optics. And these are the different type of experiments where you'll have to prove your practical knowledge in those practical situations where you'll have to plot graphs, draw diagrams, circuits, and practically show to another person that these theories are innately true. We need practical evidence for that, and you're going to prove it yourself. And this is the syllabus entailed for you this year. That is all for today, and I'll be seeing you real soon with more physics as we discuss the first chapter. Until then, bye.